In this module, we focus on controlling access to VPC networks. Cloud Identity and Access Management, or Cloud IAM, and firewall rules are some of the ways to control access to your VPC network. In this module, we start by introducing Cloud IAM from a high-level perspective. Then I will cover the different IAM members and focus on IAM roles. Next, we will revisit firewall rules to cover other ways to control the targets and sources that those rules apply to. Finally, you will get to apply what you learned by controlling access to a VPC network in a lab. Let me start by giving a high-level overview of Cloud IAM. So what is identity and access management? It is a way of identifying who can do what on which resource. The who can be a person, group, or an application. The what refers to specific privileges or actions, and the resource could be any GCP service. For example, I could give you the role of Compute Network Viewer. This provides you with read-only access to all networking resources in a project, folder, or organization. Cloud IAM is composed of different objects, as shown on this slide. We're going to cover each of these in this module. However, to get a better understanding where these fit in, let's look at the Cloud IAM resource hierarchy. Google Cloud Platform resources are organized hierarchically as shown in this tree structure. The organization node is the root node in this hierarchy. Folders are the children of the organization. Projects are the children of folders, and the individual resources are the children of projects. Each resource has exactly one parent. Cloud IAM allows you to set policies at all of these levels, where a policy contains a set of roles and members. Let me go through each of these levels from top to bottom, as resources inherit policies from the parent. The organization resource represents your company. Cloud IAM roles granted at this level are inherited by all resources under the organization. The folder resource could represent your department. Cloud IAM roles granted at this level are inherited by all resources that the folder contains. Projects represent a trust boundary within your company. Services within the same project have a default level of trust. The Cloud IAM policy hierarchy always follows the same path as the GCP resource hierarchy, meaning if you change the resource hierarchy, the policy hierarchy also changes. For example, moving a project into a different organization will update the project's Cloud IAM policy to inherit from the new organization's Cloud IAM policy. Another thing to point out is that child policies cannot restrict access granted at the parent level. For example, if I grant you the editor role for Department X, and I grant you the viewer role at the bookshelf project level, then you still have editor role for that project. Therefore, it is a best practice to follow the principle of least privilege. The principle applies to identities, roles, and resources. Always select the smallest scope that's necessary to reduce your exposure to risk. Let's talk about members, which define the who part of who can do what on which resource. There are 5 different types of members: Google accounts, service accounts, Google groups, G Suite domains, or cloud identity domains. A Google account represents a developer, an administrator, or any other person who interacts with GCP. Any email address that is associated with a Google account can be an identity, including gmail.com or other domains. New users can sign up for a Google account by going to the Google account sign-up page without receiving mail through Gmail. A service account is an account that belongs to your application instead of to an individual user. When you run code that is hosted on GCP, you specify the account that the code should run as. You can create as many service accounts as needed to represent the different logical components of your application. A Google group is a named collection of Google accounts and service accounts. Every group has unique email addresses that is associated with the group. Google Groups are a convenient way to apply an access policy to a collection of users. You can grant and change access controls for a whole group at once, instead of granting or changing access controls one at a time for individual users or service accounts. A G Suite domain represents a virtual group of all the Google accounts that have been created in an organization's G Suite account. G Suite domains represent your organization's internet domain name, such as example.com. And when you add a user to your G Suite domain, a new Google account is created for the user inside this virtual group, such as username@example.com. A cloud identity domain is like a G Suite domain because it represents a virtual group of all Google accounts in an organization. However, cloud identity domain users don't have access to G Suite applications and features. Let's talk more about roles, which define the can do what on which resource part of Cloud IAM.
There are three kinds of roles in Cloud IAM: basic roles, predefined roles, and custom roles. Basic roles are the original roles available in the Cloud Console. These are the owner, editor, and viewer roles. The owner has full administrative access. This includes the ability to add and remove members and delete projects. The editor role has modify and delete access. This allows a developer to deploy applications and modify or configure its resources. The viewer role has read-only access. All of these roles are concentric. That is, the owner role includes the permissions of the editor role, and the editor role includes the permissions of the viewer role. There is also a billing administrator role to manage billing and add or remove administrators. Each project can have multiple owners, editors, viewers, and billing administrators. In addition to the basic roles, Cloud IAM provides predefined roles that give granular access to specific Google Cloud resources and prevent unwanted access to other resources. These roles are collections of permissions. Most of the time, to do any meaningful operations, you need more than one permission. For example, in this slide, a group of users is granted the network viewer role on Project A. This provides the users of that group a lot of permissions, of which some are illustrated on the right-hand side. The permissions are classes and methods in the APIs. For example, compute networks list can be broken into the service, resource, and verb, meaning that this permission is used to list all of the VPC networks that Project A contains. Grouping these permissions into roles and having those roles represent abstract functions makes them easier to manage. Also, users can have multiple roles, providing flexibility.
Let's focus on predefined roles that provide granular access to VPC networking resources. There is the network viewer role that provides read-only access to all networking resources. For example, if you have a software that inspects your network configuration, you could grant that software service account the network viewer role. Next, the network admin role contains permissions to create, modify, and delete networking resources, except for firewall rules and SSL certificates. In other words, the network admin role allows read-only access to firewall rules, SSL certificates, and instances to view their ephemeral IP addresses. The security admin role contains permissions to create, modify, and delete firewall rules and SSL certificates. Now, there are other predefined roles for networking resources that relate to shared VPC, which allows an organization to connect resources from multiple projects to a common VPC network. We will cover shared VPC along with those other predefined roles in a later module of this course. For more information on these roles, please refer to the links in the slides. In addition to the predefined roles, Cloud IAM also provides the ability to create customized Cloud IAM roles. You can create a custom Cloud IAM role with one or more permissions, and then grant that custom role to users who are part of your organization. In essence, custom roles enable you to enforce the principle of least privilege, ensuring that the user and service accounts in your organization have only the permissions essential to performing their intended functions. For example, you might want a user to create, modify, and delete firewall rules, but have read-only permissions to SSL certificates. In this case, the security admin role provides too many permissions, and the network admin role does not provide enough. So you can select the corresponding permissions for firewalls and SSL certificates as shown on the left-hand side, along with any other permissions to create a new custom network admin role. Cloud IAM provides a UI and API for creating and managing custom roles. For more information on custom roles, please refer to the links in the slides. Now, identity and access management focuses on who, and lets the administrator authorize who can take action on specific resources based on permissions. Organization policy focuses on what, and lets the administrator set restrictions on specific resources to determine how they can be configured. The Organization Policy Service gives you centralized and programmatic control over your organization's cloud resources. As the Organization Policy Administrator, you will be able to configure constraints across your entire resource hierarchy. An organization policy is a configuration of restrictions. You, as the Organization Policy Administrator, define an organization policy, and you set that organization policy on organizations, folders, and projects in order to enforce the restrictions on that resource and its descendants. In order to define an organization policy, you choose a constraint, which is a particular type of restriction against either a Google Cloud service or a group of Google Cloud services. You configure that constraint with your desired restrictions. Descendants of the targeted resource hierarchy node inherit the organization policy. By applying an organization policy to the root organization node, you are able to effectively drive enforcement of that organization policy and configuration of restrictions across your organization. A constraint is a particular type of restriction against a Google Cloud service or a list of Google Cloud services. Think of the constraint as a blueprint that defines what behaviors are controlled. This blueprint is then applied to a resource hierarchy node as an organization policy, which implements the rule defined in the constraint. The Google Cloud service mapped to that constraint and associated with that resource hierarchy node will then enforce the restrictions configured within the organization policy. A constraint has a type, either list or Boolean. List constraints evaluate the constraint with a list of allowed or denied values that you provide, such as an allow list of IP addresses that can connect to a virtual machine. Constraints are supported by multiple Google Cloud services. Some examples that can be configured on the compute service for VPC networking are restrict VM IP forwarding, where a list constraint defines the set of VM instances that can enable IP forwarding. Restrict shared VPC subnetworks, where a list constraint defines the set of shared VPC networks that eligible resources can use. Restrict shared VPC host projects, where a list constraint defines the set of shared VPC host projects that projects at or below this resource can attach to. And finally, restrict VPC peering usage, where a list constraint defines the set of VPC networks that are allowed to be paired with the VPC networks belonging to this project, folder, or organization.